It's not something that's really a part of our requirements. And it's okay to have these bonus ideas as long as they don't affect the overall application. If this were to change how we do things, for example, if I had to capture now a team captain instead of just capturing team members, that would be a problem because that was something specified in the requirements. So I'd need to go back to the stakeholders and say, do you want this, and this is what it will take, or this is what it will do to one of your other requirements. But if it's something that's really just an add-on or extra, that might be something you could plan to do or even do if you're pretty confident the customer or the stakeholder would want it. One area that can be important or even really helpful to you is if you are in business, especially a small business, where you're building something for someone that it's not quite as defined as maybe a big company might define an application. It's really just this loose structure like this one was. Maybe it's nice to give them a little something extra so that they see that you're not only hitting your goal for the application, which is the goal would be to meet all requirements, but that you're going above and beyond. But the key here is to know when to do this and when not to do this. It's definitely not a good idea to do something like this if you're not going to meet your deadline. In fact, I would say do everything else first, and if you have time, make it better. And this would be one way to make it better. So that's really it. We've covered all of our questions and the answers we got back from our stakeholders. And out of that, we built one big set of requirements. And from that, we were able to develop this big picture design. We were also able to develop these key concepts that we might need to go out and research to understand better. Now, normally, if I were doing this in a workplace environment and I was unsure of something in my key concepts list, this is where I'd go out and start researching that. But again, we're simulating as though we know all of these because I'm going to teach you all of these. So therefore, we can kind of skip that step. Welcome to lesson number 3 in the C# from start to finish course. We're looking at data design. Now, we've already set up the boundaries for our application, the requirements that drive how the application gets built. So you've kind of built a little bit of structure, but now we're going to take those requirements and build an actual data structure. Now, at this point, some people may say, I've seen it done differently in other lessons. I've seen some people design the front end first and then develop the data later. And that's true. Some people like to design how the application looks first, and then from that, it helps them decide what to do with the data. I've done that before, but I've found the best success for me comes when I design the data first. And here's why. Your application is nothing without data. In fact, your application is just a vehicle to display, manipulate, change, and save data. Now think about that for a minute, because at first it sounds wrong. So start thinking of some examples. Let's start with something simple. Let's look at a text editor. Think of maybe Microsoft Word even. What's its job? Well, it all revolves around the text on the page. Whether it is which items are bolded, which items are underlined, the spacing, and all the rest, all of that is data, and it all revolves around that data you've given. And maybe right now you're saying, okay, sure, a lot of business applications, the basic applications, would use data a lot, and they're kind of centered around data. But certain applications aren't. For example, a game. A game is not based around data. Well, really, yes, it is. Let's take, for example, chess. Chess is all data. You've got pieces in certain locations. So you have what the piece is, what it can do, and where it's located. Then you have the game board, and where each piece is in relation to each other on that game board. And then you have the moves, and where the pieces go. That's all data. And sure, that's chess, but if we look at a more complex or a larger example, say a first-person shooter game, how can that possibly be data? Well, you have to know where your character is and where every other character is, but the system does, in order to know when you shoot a bullet, first of all, where it's going to go, that's data, how fast it's going to get there, that's data, and when it gets there, who it's going to hit, if anybody. If it hits somebody, how much damage does it do, that's data. You start seeing all the data that goes on behind the scenes sometimes, but still is fundamental to the application. It's all about that data. Again, looking at that first-person shooter game, what's the end result you want to see? A victory. How do you determine victory? Based upon the data that says all my foes have been conquered. So data is very important, and that's why I start with my data. I will often find that it's easier to develop my front-end user interface once I have my data, because I see what needs to be done, and then it's just a matter of how to accomplish that instead of just drawing from a blank slate with no information. All right, so that's enough theory. Let's get into actually mapping out our data. Now, typically, I draw this out on a legal pad or my whiteboard, and both are great ways to visualize what needs to happen, and at the same time, they're quick to change. Now, that's kind of hard for me to show you on video, so instead I kind of fast forward to when I'm done my design, I'll walk you through step by step. So what I do is development. There's a lot of scratch this out, move this around, erase this, draw a line through this, move this over here, because developing on paper is so easy to make changes. I would encourage you, and I started this course by saying, don't open Visual Studio yet. Do this development of the plan in Notepad, in your scratch pad, in a legal pad, on your whiteboard. Don't do it inside of code, inside of Visual Studio. And that still holds true here. I'm just going to show you the cleaned up end results of all that plan. I'll walk you through some of the questions that I had, the thoughts that I had along the way. So this is really where I start, a blank page. And really, this can be intimidating at first, because you don't know, where do I start? What's the best place to start? And the answer is really just put something down. And so I said, well, let's start with team. I know I need to have some kind of team that has people in it, that has a team name and all the rest. So I started with team. And I said, on that team, we're going to have members. And in parentheses, I put, this is the type that I think we're going to need to have. So I said, create a list of type person. I don't have a person list yet. And maybe at that point, I'd pause and say, create a person list. But my focus is on, let's just get the team built first. Now, the other thing here is, I don't typically put types in until after I've come back through. But in this case, I'm showing the end product. And so I put the types in there, but really what you want to do is you want to get all the information about team down first before you do anything else. Don't worry about types now, but do a second pass. After you got all the data in place, do a second pass and assign types to each one, just to make sure you understand how this whole thing is going to work. Again, since I didn't have a type person yet, I'd make a note of that, but not actually develop the person class, the person group of information yet, because I'm focusing on team. If I leave team to build person, I might forget where I was in team and miss a key component. So always focus on one thing at a time. Everything else gets written down for later. So I have members. So that would be the number of people on a team, which could be one person as a one-person team, say for our ping pong tournament, or it could be 5 people, say for a basketball team, or it could be 20 people, maybe for some kind of office game. It doesn't really matter. What really matters is, do we have that list that can have really 0 or more, but in our case, we kind of want to force it to have at least one person on the team. The team name. We know that each team has to have a name in order to call it something better than Tim, Bob, Mary, Sue. Oh, that might be a great team name, who knows? And that'd be a string. So that's really all the team class is. So let's move on to person. Since we created this list of person, let's go ahead and now create that person object so we get that out of our mind too. We have a first name, which is a string. Straightforward. A last name, also a string. We could have asked for just a name, add first and last name together, but I find that breaking that apart into 2 different properties, 2 different data points, is first of all best practice in the industry, meaning the industry does this by default or does this most of the time. but also it makes it a whole lot easier for us to do things like have an email where it says Dear Tim. It seems more personal that way instead of Dear Tim Corey. So breaking apart into two different objects and having the user break that apart is very important. You could say, well, I know how to break a string apart based on a space. Therefore, Tim Corey could be in that very well to break it apart and say the first part is the first name, the second part is the last name, which only works when the person only has one space in their full name. What if, for example, they said they had a last name that has space in it? Van space Wilder is the last name, Van Wilder. Well, that would come out as split apart. That's a problem. Wilder is not the last name. It's Van Wilder. First name is Joey. Same thing is true for first name. If first name is Mary Sue, or the first name truly is Mary Sue, so they put Mary Sue for first name. Mary Sue Smith, if we broke that apart, we'd say the first name is Mary, not Mary Sue. So breaking things apart, you get ugly really quickly. Instead of breaking things apart later, you put them together later. And that also allows you to do interesting things like last name on first name, or first initial last name. Let's look at the next property. Email address. They capture the person's email address, and that's also a string. And cell phone number. And that too is a string, and that trips some people up here. The idea that right in the name, cell phone number, and yet we're not saving it as some type of number, whether it's an int or a double or anything like that. We're storing it as a string. And the reason why is because we don't treat a cell phone number as if it were a number itself. So for example, the number, we can add to that, we can subtract from it, we can divide it, multiply it. But doing that to a cell phone number doesn't make sense. We wouldn't add to a cell phone number for any reason. The cell phone number is what it is and it never changes. Also, we might want to store some kind of formatting. For example, around the area code in the United States, we put parentheses and put a space. And then after the first three numbers, like the actual phone number, put a dash. And the last four. If you do that and store it that way, you might say, well, yeah, but I'll store it as just numbers. Well, that's great. But it still doesn't get past the idea of this isn't really a number to the original. So we're going to store it as a string. And you may have caught me saying a couple times properties. And I want to stop for a minute and point that out. Really what we're doing here is we're creating our classes. So a team is going to be a class, a person will be a class, and inside those classes will be these properties. Now it's not a direct one-to-one matchup right now because, for example, cell phone number. I might change it to cell phone or phone number or something like that. But it's a pretty close matchup. Now there may be other classes we create, but these are really our foundation classes on which the application gets built. These two plus the other one we'll talk about in a minute. And I don't want you to get too caught up in the idea of code, but I do want you to be thinking about the fact that really these do map up pretty directly to classes, which is why I call these items properties. So just keep in the back of your mind, when it comes to actually building our class library, having our data mapped out like this makes creating our foundation of our class library so very easy. Okay, back to our data. Our third class, or our third set of data, we'll call tournament. And this is all the data that surrounds the actual tournament, which is what this entire application is based upon. This is a tournament tracker. So this is going to be the central data hub, or central bit that everything revolves around. So the first thing we need is a tournament name. Now that's not specified anywhere in the requirements, but we do mention the idea that there might be more than one tournament at a time. And so if there's more than one tournament, how do you know which tournament is which? You could look at who's playing them and what round they're in and all the other details, but really that's so imprecise. So instead, we're going to specify that every tournament be given a name. That way you could say ping pong tournament, basketball tournament, and then you know exactly which tournament you're talking about. Next, we'll have an entry fee. Remember we talked about the idea that we could accept fees or could say that every person or every team needs to turn in a fee? Well, this entry fee is going to allow the administrator, the person that sets up a tournament, to say there is an entry fee to this tournament and it's $10, whatever it is. And then every time we add a team to the tournament, we're going to charge that team the entry fee. So that would be a type decimal. And that's something else to point out. We'll get into more of the C# after we're actually inside Visual Studio. But for now, I just want to point out that because this is money, this entry fee, we should store it in type decimal, not double. On the surface, these two data types look very, very similar, decimal and double. They both store numbers that have a decimal point. The difference is precision. Decimal is very, very precise, but it also takes a lot more memory. And so we typically only use this when we're talking about money. Double is a little less precise, but if you look at the actual precision, we're still precise to about, I believe it's 14 decimal places or 14 places after the decimal. That's good enough for me. But in the case of money, we really should have decimal. Okay, I mentioned that the entry fee is going to be charged, if there is one, to every team that enters the tournament, which means we have to have a list of teams in the tournament, or I call it entered teams that have entered the tournament, and that would be a list of type team. The great thing here is when we're developing this tournament, we're not thinking about, oh, I have to enter the first name, last name, email address, and phone number of these people who were on teams and all the rest. We're just concentrated on what the tournament means. Even if we hadn't yet created that team, that list of person called team members, or anything else, we could say, I just need a list of teams. And then from there we could say, okay, in a team, this is what I need. And then in a person, this is what I need. And so really when we're developing this data, we can't move too broadly. We have to focus on just what makes sense for this particular object, this particular chunk of the data, what goes together. In this case, we're talking about tournament. So the name of the tournament, the entry fee, the entered teams, and then also the prizes. The list of prizes contains just that, a list of prize. What's a prize? Well, we talked about the idea of having, for first place you get half the money, or first place you get $50, whatever we want to do is in setup. So we need to have a list of those. And this list, it truly is a 0 or more list. Maybe you don't have any prizes. Maybe you have one, maybe you have 15. The next property for a tournament is the rounds. And this one's a bit tricky. You gotta think through how it's going to work. Now we haven't built the matchup object yet, but a matchup would be one team versus another team. So we're going to have a look from the middle out. So we have a matchup, that's one team versus another. We're going to have a list of those matchups per round. So our list of matchups is round 1. Another list of matchups is round 2. Another for round 3, 4, and so on. So one list represents one round. Therefore, we have a list of matchup. You get that? You might have to draw it out on paper to think it through. We have matchups, but then we have a set of matchups that represents one round. And this rounds property holds all the rounds. So it has multiple lists, one for each round. Thus, the list of a list of matchup. And that's really what the tournament object contains. And at this point, there's a couple things I want to point out. First of all, we don't have the prize object or the matchup object yet. That's okay. We've written those down as we need these. We'll get back to them. We're concentrating on tournament. The other thing I want to point out here is there's going to be data besides what you have here. You're going to miss stuff. You're going to not think things through all the way necessarily. There may be things that